You want to answer? Oh,
Well, that's okay. We'll do it anyway.
Okay, good morning, ladies and gentlemen. My name's Tim Downs. I know many of you, and there's many of you that I don't know. Some familiar faces, new faces. Our company is called Wireless Enterprise Professionals. Ashish and I launched this last year. Our goal is to help bridge the gap between those of you who are vendors in this room and those of you who are trying to either put private 5G, private cellular in your enterprise, or use it in your systems integrator business to accelerate more service and value for your enterprise customers. Before I get going and kick it off over to Ashish, I would like to say this MXD USA place is very interesting. We love it here. You'll be able to have a tour after this program is over, about 2:30, 3 o'clock today. And what I thought would be really great is to hear from MXD themselves. So please give a warm welcome to Brian Townley of MXD.
Hi, my name is Brian Townley. I'm on the business development team at MXD. Just really quickly wanted to say, really happy to be hosting all of you here. For those of you who don't know, we are a neutral nonprofit, what's called the Manufacturing Innovation Institute. So we're Department of Defense funded and primarily focused on helping manufacturers adopt more technology and secure all of that technology as well. And so wireless is a huge part of that conversation. We get all kinds of manufacturers and universities asking us questions about wireless all the time. So really happy to be here at this event and supporting education around private wireless.
Great. Thank you very much. So when it comes to the tour, so you'll be leading it, or how do we do this?
Yeah,
We'll just show up at the front doors there this afternoon?
Yep, you can find me whenever, and I'll be leading the tour this afternoon as well.
Okay, great. Thanks a lot, Brian.
Thank you.
All right. Well, as I said, look, we have been advocates for private wireless in the enterprise for many years, Ashish and I, and we still believe that, that the wireless industry's biggest opportunity in front of it is to assist enterprises in their digital transformation, plain and simple. How we get there, we think, is through education and collaboration and information. That's what our job is. And so a lot of you already know a lot about private networks. Some of you do not. The idea here is to open up a very honest and open exchange of information. I think what you'll find is Ashish has put together really top quality content. We're recording this, and we hope to do this all over the country, and of course grow our audiences as we do that. As we grow our audiences, your customer base grows too. So any help, any suggestions, any advice that you can give us in how we message our industry to the enterprise, how we communicate the value, that's really important to us. Are we using the word private too much? Should we be focusing on edge or AI? Or what is the message that's going to resonate with enterprises that say we really need to examine this technology and we really need to find a professional, certified, knowledgeable partner in this endeavor? So that's our goal. Thanks for showing. Thanks for being here. I'm going to turn it over to Ashish Jain, my partner. Ashish, take it away.
All right, guys, thanks a lot once again for coming here. I know some of you are very entrenched in this market and some of you are just getting started. So we have put together an interesting program today to give you a lot of information. And in any information session, there's always things that you already know, and there are always things that you'll find out interesting. And the line of speakers we have, I'll start with the session on rising importance of wireless to enterprises. And then we have Jason Tyner from Revels, who's going to talk about how LG is using private networks. Kurt Jacobs from Ongo Alliance is going to share a lot of other use cases. We have a very interesting presentation from Harpreet Geeky from Shabodhi. I think that's something unique you will see. I can guarantee you probably have not seen that. I can bet on that for sure. And then right after the break, we'll go a little bit more deeper into the fundamentals of what is private cellular 101 from an enterprise perspective. Understanding the private cellular ecosystem, we'll have Todd Landry. Many of you know him. He's going to present a perspective on that. We'll have Eric Randall from Bicells talk about the overall how do you navigate an opportunity. And I forgot, from a private cellular 101, we'll have Mike Ovens from Betacom presenting, as well as Ian Watson from Aura Wireless. Another name you probably have not heard in your ecosystem, and a company you should absolutely know when we talk about private wireless in general overall. We'll end up with some Q&A, but to be honest, the Q&A needs to be throughout the session. If you have information on anything, please feel free to share. This is intended to be a more close-knit discussion. It's not about us just presenting, it's about learning from each other. And that's really the intent of this session. A bit about myself. I've been in the industry for a good 15 plus years, specifically in the telecom side. I used to work for a company called Ribbon, which we used to call Genband before. My partner there from Genband is sitting right behind taking my pictures because he loves me. But at that time, I saw a big gap in the market is we talk too much tech. We talk too much jargons. This particular industry is too spoiled about using acronyms, and 3GPP hasn't done any justice to anybody from that perspective. They keep throwing new words, new acronyms every year. My role there was to really make sense out of those to the enterprise, make sense for those who are selling that technology to their customers, and bring in an outside-in perspective. And that's really what motivated me to start a company called Kairos Pulse several years back. And I've been working with many vendors, SIs, enterprises, service providers in that capacity, helping them make sense of technology. How do you go to market? How do you communicate? Private cellular, I've been involved in this space for the last, I would say, 7 years, even before it was actually called private cellular or anything like that. And I help many companies do that. Again, I saw an education gap in the way the industry was talking about it. I started a publication called Private LTE and 5G. You might have seen that because I shared a lot. I actually had a celebrity moment when the CEO of MXD yesterday said, "Hey, I know you. You're Ashish from Private LTE." I was like, "Great, people know that we are pushing something out, great out there." So the intent of that education was really, giving a lot of information. But what I saw was we really need to go a step further. So Tim and I have been talking to each other about this for the last 3-4 years now. And last year we said, you know what, nobody's doing it right. Let's start ourselves. And the intent really, at the end of the day, I'll reinforce the message, is about starting sort of an accelerator program, right? When you're a startup, you go to an accelerator, it gives you the resources you need, it gives you the infrastructure you need, it connects you with the right people, and it tells you how do you actually go run your business. Although we're calling it an accelerator, it's an accelerator of how do you go to market, how do you go message this, what is actually needed by the enterprises, help them connect with the ecosystem. So there's going to be both aspects of creating a lot of educational content for them, but education not in a perspective of, okay, what is ORAN, what is 5G SA, what is radio? Great, I mean, all those details are very much required, but the fundamental gap that we've seen is understanding and connecting the dots with, okay, what is an enterprise problem? How do you solve it? How do you bring in and find out what's the right technology to solve the problem? So our intent of the learning and the practical know-how is going to focus a lot on that aspect versus just the technology aspect. And then, of course, we're building a large community of not just the networking and infrastructure providers, but also the biggest gap I felt was people don't know what kind of devices are out there, what kind of applications are already supporting these things. And I have my podcast, I've done a lot of those. And I find out and I get surprised, like, okay, this is happening actually. People are using it. We're going to build a lot of ecosystem as part of that. So the intent really is to be that accelerator, be that support engine for the entire ecosystem to understand how to go to market with this. All right. So the rising importance of wireless to enterprise. I'm going to start with a question here. If I throw out a word private networks, what's the first thing that comes to your mind? Are we talking about private 5G? What comes to your mind? Is it private 5G, private 4G? What comes to your mind? Great. Non-public network. Okay. Great. Not controlled by a service provider. What else? Wi-Fi. Okay, great. What else?
Local network. It's something you keep locally.
Local network. Okay. Who thinks the term private resonates with an enterprise? Okay, any business who is using network for connectivity. Okay, it could be in manufacturing, it could be a warehouse. When I throw a word private, is this new to them or is it something part of their like daily life? Everything for them is private. This context of private is new to the cellular world. Okay, and we get too excited about it. Okay, and I think that's the fundamental problem. Is we talk cellular, we haven't got them excited about the benefit of cellular first. It's like, you got to join my religion. Okay. And it's like, okay, now that you've got in, I got to tell you what you need to do, how you got to do it. But right now, the religion is Wi-Fi. The religion is, SCADA. The religion is Zigbee. The religion is BLE, whatever, right? They're looking into wireless in that context. And that's how we need to educate them. What are the new options and what's the benefit of that option for things they're trying to do? All right. So for the next 30 minutes, I'm just going to talk about that. But before that, why you should be excited. So automation and digitalization, how many of you think that this is actually happening in the enterprise world, whether manufacturing, warehouse? How many think it is actually happening? You think, people are spending money, a lot of money, right? Why are they spending money in that? Examples? Make money. Okay, what else? They're doing it for fun or they're getting something out of it? Driving down the labor cost. Good example. What else? Efficiencies. Okay, what else? Security. Okay, what else? Okay. At the end of the day, it's about their efficiencies, the cost down, and most importantly, customer experience. They are trying to figure out how do I connect my technology to my customer? How to connect my products to my customer in a way that improves their experience, improves my efficiency, reduce my cost down, and ups my margin, right? At the end of the day, any technology has to serve those goals, one way or the other. And what they're realizing is a lot of data is required to do that. They have to create a lot of data to create. And okay, AI is going to play a big role in it. If you look at the word AI, this is on top of everybody's agenda right now. How do I use AI to make my business run better? How do I make my experience better? How do I reduce my cost? Everything, right? All of this is going to generate a lot of data. And these numbers are, I know everybody, I've come from that side of the world where, a lot of numbers are inflated to just make it look good. Even if it's, 50% right, it's still a big number, right? So this is something Rockwell recently came out with the state of the manufacturing report. I found this very interesting because technology investment is increasing by 30% year over year for manufacturing. And where are they investing? They're investing in, using artificial intelligence. They're investing in digitalization and automation, and they're hiring new and different people, right? Workforce skill set, right? Skill set to do digitalization, skill set to do automation is one of the biggest problem right now, not just for manufacturing, for any industrial setting. They're trying to invest money in how they do, how can they improve both from an external risk mitigation as well as an internal risk mitigation perspective. Those are the kind of things. If you go to an enterprise, go to any business and start talking about cellular, it means nothing for them, right? It means nothing for any technology for that matter. It has to connect it back to what they're doing. How does it serve their purpose from an external risk mitigation and internal risk mitigation? how did it serve them in terms of operational efficiency, improving workforce productivity, and increasing the customer experience. At the end of the day, these are the kind of things that resonate with them. So what has happened over the period of time, one thing which is an interesting perspective I put out there is all this digitalization that is happening has really created a boomerang effect. What is the boomerang effect? Right? If you look at all this digitalization has happened a lot in the IT side of the equation. So cloud deployments have actually served quite well in for them to understand how everything has moved to the cloud. Operationalize that, the SaaS platforms has given them a lot of agility, a lot of operational efficiency. But there are two sides of the business. There is an IT side of the business, and then there is OT side of the business. Right? There's an operational technology side of the business. Operational teams and operational intelligence does not value agility and openness as much as the IT guys do. They value security. They value control. So a lot of the mindset of putting everything in the cloud hasn't really happened on the operational side of the business. Now it is actually happening now because they're being questioned why all this data is sitting, why I'm not improving my efficiency, why I'm not reducing my cost. So a lot of connectivity is happening. What does that mean? But OT guys are not going to go give out the control. They're still very wary about the security. But that mindset of the cloud agility, they want it. So how they want it? They want to put it in their network. And that's where the edge cloud has become a thing of importance for them. How do I control my data? How that data doesn't leave my facility? How do I connect all my devices without losing the control, but still getting the efficiency that I need? So this is another interesting perspective. So over the last 15 years or so, the digital applications have grown 162 times. 162 times. And think about what AI will do. This will blow it out of the water. A lot more applications are going to get developed and implemented by enterprises in all verticals to keep growing this digital application. But the underlying network that supports it hasn't grown that much, 42 times from a bandwidth perspective, 2x, only twice from a modernization perspective. So a lot of this gap from what the data volume, the applications are going to be versus the network that underlying supports it. And this is very important for you coming from Ford, right? You're doing data analytics, right? How much data are you going to collect from where? Is your network really ready to support that? Does it give you the information at the time that you need? It gives you the results and outcomes, as quickly as you want. That kind of infrastructure gap is there. And I think there are a lot of technologies out there. Like I said, wireless is not new to enterprises. The word private is not new to enterprises. It's just another technology that we have to look into that serves the purpose now. We think 4G, 5G, one way or the other, from a cellular perspective, is a decent technology that serves that purpose. Wi-Fi is not going anywhere. It's still going to be there for many, many things. But I think the combination of Wi-Fi plus cellular is going to be a critical infrastructure for many businesses going forward. Whether or not they do private edge, however they construct that infrastructure is up depending on the business. But at the end of the day, you're connecting data from devices to the applications. And that application could be sitting in the edge, sitting in the cloud. However, the underlying reliability and efficiency of a cellular network is better, at least proven in many cases, to provide that. So we think that infrastructure is critical. Again, another number on the screen, $9 billion opportunity by 2028. Many analysts talk about this as $20 billion opportunity. Doesn't matter. It's growing double digits. There's opportunity everywhere. If you think these deployments are not happening, they're actually happening quite a bit. There are almost 6,000 enterprise sites that are already using it. A lot of time you don't get to see it because they're not publicly announced, or they don't count it properly. If one manufacturer does it, it's counted once versus if it's done in 20 factories, right? So the deployments are happening, the confidence is increasing, and we think the SIs and MSPs are playing a big role and will continue to play a big role. Anybody who has the expertise to bring it all together, not just from a network perspective, but also bringing in the infrastructure, whether it's cloud or edge, bringing in the devices, and more importantly, connecting it with the application. I think that's a very important point. It depends on the application at the end of the day, right? So if you look at, and I have this as a one of the talking points later, if you look at wireless communication, I look at it from three perspectives, right? Any technology for that matter. There's an application, which is how critical it is to get that data from point A to point B. Like if you're going on a highway, right, and you have to catch a plane, and your plane is in 30 minutes, your flight leaves in an hour, and you're going to miss a flight, you're not going to care much about you paying $40 or $80 to get there, especially if that meeting is important and you're making a lot of business out of that, right? Same highway, nothing has changed, right? Your flight is 5 hours later, and even if you get late, you're not going to pay $40, $80. You might even try to figure out how do I get it down to $10, right? So it depends on the application criticality of that data.
And it was fast, that one.
Yeah.
The same thing happened today. For the fast, it happened.
Yeah.
The application may not be there today, but there's a number of bills.
Yeah, no, I think there are many areas where every technology is advancing, right? Wi-Fi has gone better, much better in terms of how much bandwidth it can carry. It has gone better in terms of the performance it provides. Like I said, there's going to be criticality of the application. Then the second aspect is always I look at technology, how reliable the technology is to get that data from point A to point B, how much it can carry. Of course, the third aspect is spectrum. Spectrum is always finite, right? Especially when we talk about in context of wireless, that is a finite asset. How effectively you utilize that? Which technologies makes the data go further, more efficiently, more data. So these are three aspects that I always look at when I evaluate a technology and say, okay, which technology makes sense for which application? Fourth one, which we tend to ignore many times, how much control it gives you. So you really have the way to say, okay, I want to enforce my user policies, I want to enforce my data policies on it. And I think that's the reason why a lot of these aspects of wireless are being evaluated. Why different other technologies have made it into enterprise than cellular is because of that control. A lot of enterprise want that control. So we'll talk about latency and all that. I think that's what the presentation is going to talk about that.
Any comment? Private cellular environment, the Wi-Fi devices and the Wi-Fi network. How many of you see that a really hybrid network, private cellular and Wi-Fi network connected to the
I would say the hybrid is pretty much every environment. Whether that same device is connected over the same, hybrid network is not, I would say, as pervasive as we would want. The reason being, a lot of applications initially are designed to solve, okay, I have a problem with my RFID scanners. Okay, I can't get the connectivity in this part of the network. To be honest, I mean, if you're putting cellular network on a factory floor, that same iPad, the same tablet that you're using to punch in numbers on, the status of that machine, on the factory floor, you're connecting over the cellular network, and when you lay a room over, you still connect over the Wi-Fi network. It's not, you're not at a point where it's optimally deciding whether I use a Wi-Fi network or a cellular network on the fly. The dynamicism is not there yet. But I think that would be something which the industry is trying to solve.
You have to be afraid of the private cellular.
Yeah.
Because you're still going to have your familiar Wi-Fi environment with your devices that are ready for Wi-Fi. And then my perspective is that the finding is that the end devices are not fully supporting cellular, private cellular yet.
I think
They're coming, but
I think there are a lot more than you think, and Todd is going to talk about it.
that's important.
Yeah, I mean, of course, right? It has taken, how long has that taken? It has taken more than 10, 15 years for Wi-Fi to become, a household name, and everything supports it. Trust me not. I mean, every cell phone supports LAN 48 today, CBRS. right? It's a matter of how do you configure it, enable it. So that's the gap right now in the industry is the expertise to provide that information. And that's the reason why we started. It's like when we get a question like there's not many devices who supports it, and I'm like, no, actually there are many devices that supports it today. And people just don't know that they exist. So we'll talk about that.
You say another advantageous part of private cellular is its cohabitation with other advanced wireless.
Yes.
Right.
Yeah. It is designed to be, actually, if you look at 5G, it's designed to be an access agnostic technology. It has not been implemented that way because everybody wants to serve their own purpose at the end of the day. But truly, it is designed to be an access agnostic technology, and we're looking forward to see solutions, that can actually bring the intelligence of managing both networks together. All right, so successful best practices require 3 focus areas. Nothing new to you guys. Many of you always, have a compelling ROI model, compelling business use case. Now, I don't want you to get hung up too much on, oh, I have to put together a very sophisticated ROI model. At the end of the day, you have to work. Everybody will have their own way of justifying the case. You have to know what the right questions you need to ask. How do you put that into perspective for an operator, for their enterprise? But integration methodologies is going to be the key differentiator. If you go and talk about a solution that is totally independent, you're managing it, IT guy is scared of, oh, how does it relate to my environment? I have no visibility, I have no control over, what SIMs I provision and what data I control. That is going to be a challenge. Integration with enterprise ecosystem is the key to make this technology find its way in their deployments. And again, education, I can't stress enough how much that part is important for us as an industry to tell the business leaders, the business stakeholders on the value of this and how they can utilize that. Okay, I'm gonna quickly go through a number of things. Understanding wireless network needs. Okay, let's switch gears a little bit. And I'm gonna ask everybody, smart manufacturing, I'm sure everybody has heard it. We are at MXC Center. Everybody know what smart manufacturing is. Give me examples that you know of smart manufacturing. Robotics, okay. Okay, that's an overall category, yeah, okay.
The paper, right.
Okay.
Yeah.
Paper reduction.
Another home back.
Okay. What else? Anybody? Asset tracking, okay. Predictive maintenance. What else? Predictive failure rate, okay. What else? How do you use the data? Okay. Anybody else? Examples of smart manufacturing? Okay. Might be an eye chart. This is what they think, right? Production monitoring and ERP, supply chain planning, quality management systems, production logistics, analytics, robotics, somebody said, smart devices, industrial control systems, power control, design and visualization, asset performance management, computerized maintenance management system, distributed control system, manufacturing MES, manufacturing execution system, right? This is their language, right? We got to find ourselves in that language. In every single one of them, how is data changing? How is connectivity required? And what are the use cases for each one of them? If we go start talking about latency, if we go start talking about bandwidth, it's given for them. You got to connect the dot by saying, okay, Mr. Customer, you're trying to do quality management system. Okay, here's an example of quality management system. In every assembly line, manufacturing is now putting smart devices. Every assembly line has its own network. Can you imagine? Every assembly line has a CPE installed where all the tools are connected to that CPE, pushing data into some data ops platform like Litmus, where they're actually showcasing how many times did I, how deep I drilled it, how many, what was the torque when I screwed it. Every single data, especially in high-end manufacturing, is being tracked. What do you think is a loss of business if that data is delayed by 3 seconds. 3 seconds. Okay? The data of somebody's trying to use a tool, because these are sophisticated tools, it needs to have an authorization that I can use this tool and I can transmit data. If that tool doesn't connect to the system for 3 seconds, and it happens multiple times, how much do you think that loss is for the manufacturer? Yes, right? And having this assembly line set up with every line with its own network, how much time do you think it takes now to roll that out? If they do with traditional network. Right now, what they do is Ethernet cables, CPE, cloudlet, wires going through, everything is connected. And then when we do the tour, you will hear about flexible manufacturing, which means the machinery is not set up at one place, it keeps moving. Okay. So the cost of the amount of time it takes them to set up network on one assembly line is anywhere from 3 to 6 months. Okay, that's because they have to run cables, they have to do all the closets. And if you convert that into wireless, it runs just faster. So they're able to create a connected operation line in less. If you cut down that time with 2 months, that's your ROI. If you save them instead of 2 minutes of downtime a day to 30 second downtime a day, it's saving. I mean, it's an interesting stat that in manufacturing, they built in inefficiencies of 800 hours of downtime. 800 hours of downtime. That's $200 million of inefficiencies built into their business model. So can you go out and help them save 50 million? That's how we need to be talking. So whether you're selling a solution for $500,000 or 2 million, doesn't make any difference if you're able to tell them that you're going to save them 50 million.
These going right on the key part of the technology side is uptime.
Uptime.
Everything is about uptime. That costs of money. Stuff.
Yeah.
That's key, I think, for us when we deliver. How do you improve that uptime?
Exactly. Right. So when I picked up manufacturing as a use case here because that's one of the focus area, but this applies to every industry, right? They're investing in networking hardware, they're investing in software, they're investing in connected devices. When this is happening, whether that networking technology is going to be cellular or Wi-Fi, it's up for us to decide. A lot of time, manufacturers, they go to their trusted circle of people, right? And they will ask them what is the right solution. If that trusted circle is only going to lean back to traditional way of connecting, they're going to do what they've been doing, and they will find out a year later that was not the right solution. I just had a conversation with Jaguar, a VP of product management, a couple of weeks back, and he was frustrated, saying, "Guys, you don't know how to sell me." So for 3 years, people kept asking me, "What is my problem? What is my use case?" And I said, "But the moment we actually tried it, it's the best thing I've ever done." So we actually are not going out and selling it right. Okay? All right. This is not my words. Biggest ROI over the last 12 months for manufacturers. Okay? 5G sits there, the third level. More than MES systems, more than RPA, more than robotics. Right? They're seeing the value, they're seeing the benefits, and where they're going to invest in the next 12 months. They're going to invest a lot in Gen AI. They're going to invest a lot in collaborative robots. They're going to invest a lot in this AMRs and AGVs, zero trust architecture. I mean, think about it, right? Network plays a big role in that zero trust architecture. AI, ML, industry, metaverse, on and on and on. These are the areas we need to align ourselves and say, okay, how do we fit in any of these investments? Why are they investing? For exactly the same reasons, right? Whether it's 5G is an overall term of saying cellular, right? At the end of the day, when I spoke with folks from Airbus, I spoke from Jaguar, many other companies. The biggest point is my current network doesn't work on the shop factory floor. So if I go back to this, right, factory floor is their pain point. On factory floor, nothing works. We visited John Deere a couple of weeks back, and after months and months and months of analysis, they figured out that during lunchtime, I lose every of my connection. Why? Because everybody turns on microwave to heat up their food. They of course are, right? Jason Warren has been a very big adapter for this. But the problem is, I mean, this is not new, right? Every facility you go to, they will have microwaves to heat up food. Every facility you go, they will have metal on the factory floor. Doesn't work. It's their words, not mine, right? It doesn't work. We're losing business. There's a reason why they're looking for alternatives. There's a reason why they want, newer technologies to connect their systems.
Simple example, one of these companies, a large warehouse facility in the class, or south side of Chicago. Talking about, they got ABVs. In the warehouse, they have over 4,000 Wi-Fi access. Think about this problem they have every day, an access point that we kind of study. If I could put cellular, how much is my problem go away? How much is my uptime?
So that's exactly the point I was trying to get. Is it pervasive connectivity?
Yes.
Is it more efficient operation?
Yeah.
Is it more efficient utilization of the network?
Yeah.
Is it availability of the network services for applications consumed and operate much more better? So somebody asked about latency. Is it that I can actually prioritize latency for this device, this PLC over that kind of controller, kind of stuff? So there are a lot of additional costs that we are seeing in the market today as well. Just to
Yeah.
And by the way, I used to work for Cisco, so I'm very grateful to whoever bought 4,000 APs.
So just to your point, right? Criticality of wireless is rising at the end of the day, right? So let's first of all say, okay, up until now, a lot of networks utilize fixed network, right? There's still, Ethernet going on. There's still fiber going on. I mean, it's mind blowing when I heard Jason say I have 1,000,000 miles of cabling in my factory. 1,000,000 miles. 1,000,000 miles. Right? Think about them changing it. For the flexible manufacturing, I need to this Cat5 cable, this move there, that move there, right? And unions, right? At the end of the day, getting the contractors to come in and do it, it is impacting business. So people are moving towards wireless, one way or the other. Whether they will use Wi-Fi, they will use, some sort of a, IoT technology, they'll use cellular. The application will decide that. I'm not saying cellular is the only way. And, Harpreet is going to talk about, how actually you can utilize the network asset even, in a hybrid scenario, whether it's Wi-Fi or cellular or SCADA or whatever, right? The connectivity mechanism you're using, there's a way. The industry has been looking at network today as a pipe. I need data from point A to point B. And what's my criticality of it? What's my, how quickly you can get it and all that. SD-WAN kind of tried to bring in some programmability to it. Okay, I can figure out, dynamically where do I steer the traffic, all of those things. Wireless hasn't seen that as much. And I think this new era of what I call it programmable networks are coming into wireless as well. And that programmability of network ultimately is going to make the application experience even more better. So we're going to talk about some of that aspect today.
Introducing a lot of that more reinvestment. That on the history is sort of going into a brownfield application is going to be a hurdle itself. So
Either way, you're going to be upgrading that technology.
One way or the other, timing might be different.
5 or 10. You're going to be upgrading those 4,000 APs. So every 5 to 7 years. Yeah. Right? You have to refresh. Otherwise, my old company will stop before it.
Yeah.
If you go to a refresh every 7 years of an enterprise network, no matter what switch you have, no matter what router you have, what AP you have, what wireless LAN controller you have, it has to be a free one.
Yeah.
Right?
Well, I'll tell you a business case that one of the higher education did was they were evaluating how to upgrade from their Wi-Fi to Wi-Fi 6. And the business case of upgrade was much more expensive than putting a CBRS network and just extending the shelf life of their existing Wi-Fi network. Those are, different use cases. It's how do you combine, and that's where it comes down to your question somebody asked earlier, coexistence, right? CBRS or cellular can even extend the shelf life of their existing Wi-Fi networks. But anyway, this going back to criticality of wireless is again going back to the point on more and more applications are going to rely on wireless. It's no longer about the IT applications; it's about the operational applications. And Harpreet used the right keywords here: deterministic, consistency, and scalability. What that means is I should know that my network will perform at a certain level all the time, right? Consistently give me a quality. Consistency is key. They don't want surprises. And then it can scale, which means it will give me the same performance even if I add more devices. It can scale if I extend the geographic scope of this network. So these are the kind of things where the newer applications demand are very different. The enterprise expectation is very different. We talked about data security and data sovereignty. That's big. I mean, if you're dealing with anybody from operation technology, they don't want their data out. Simple and clear. They will not put their data in the cloud. So how do you do this? Actually that's why edge applications are important. All the applications are running there. How do you connect your device to that edge application? You need a reliable network. And we already talked about the downtime. And the numbers are huge. The smallest of the business downtime cost is almost $500 a minute. Okay. In manufacturing, it goes up to $9,000 per minute, even more. The average number is $256,000 an hour of downtime. There are industries where it is almost $1 million per hour downtime. So going back to the point of uptime, keeping it uptime is huge, huge. Not because you're running a video call. It's because you are connecting a machinery data or some other operation technology data, your tools, your devices, the availability of the diagnostic, your worker safety applications, the remote surveillance, the quality control on the, of those things that you're monitoring. All of that is business critical. So for any business critical application, wireless is a critical infrastructure. Okay, so enterprises are trapped with two choices, right? If I leave the IoT things for a minute, if you look at, they have primarily two choices. When we say the word private, most of the time you will say Wi-Fi, and when we say public, most of the time you will say public cellular, right? Those are the two kind of train of thought that normally people have. These are the two choices they've been using for years. So if we let's understand the limitations, right? So these are on the left-hand side, you will see the enterprise needs, which we've already been talking about: deterministic performance, consistent quality with scale, seamless indoor-outdoor mobility, depending on, again, if you have AGVs moving around, you want that mobility to be functioning all the time. In fact, Jason will talk about that use case. Network ownership and control is huge. Data security and sovereignty is huge, and cost of ownership at the end of the day. Do we agree? I mean, these are the five. Can we say these are some of the most important criteria for evaluation on any technology for enterprise? Yes, no? Okay, people are nodding. I'll take that as a yes. Okay, so if we look at each of these scenarios, Wi-Fi is great. It works, but the moment you try to bring in critical operations on it, it does have its shortcomings. It is getting better, no doubt about it. When we have Ora from here, they can tell how it does function in many cases, but it is being told by enterprises, not us telling, that there are critical applications where it is challenging. Cellular, the technology is actually pretty good, but public doesn't work that way because there's no SLA guarantee by any operator to provide that. Unless they are going in, putting slicing, actually operating like a private network, not running off of their public cellular infrastructure. Indoor outdoor mobility, Wi-Fi does have a challenge from a handoff perspective. It has gone better, no doubt about it, in years. But if you're really looking for wider network handoffs, definitely cellular has built-in capabilities to support those kind of things. Again, public cellular is good, but we do know cellular doesn't work indoors all the time, especially when it's a public cellular. Network ownership and control, very, very high. I'll give a mark, rates for Wi-Fi to be, that's why all these technologies are actually made in. Public cellular, definitely not. Data security and sovereignty, again, the same thing. Having said that, I think there is a fundamental benefit from a cellular perspective. It's a SIM-based authentication mechanism versus a password-based authentication, which assures the device is secure, not a user, right? So that particular device, they can control policies versus who's using that password, right? Cost of ownership, I would say now Wi-Fi definitely, has its own benefits. But if you look at in a bigger context, I mean, if you're giving examples of 4,000 APs versus 8 APs, there is a benefit to that. I think overall, when we start putting in cost of ownership, it's starting to get comparable. Now, I'm not going to say that it's going to be comparable for every vendor that you work in the room. Everybody has their own price points. So you do have to figure out what price points, are, give that justification and who is the right ecosystem to work with to get that price point attractive. Like I said, emerging technologies, private cellular does meet a lot of that need.
What are some of the challenges that we are facing? Like power normally from going also not really more, right? You will have to connect with the education, to talking and that's what I think that is also I mentioned about the wireless and manufacturing goals.
Yes, absolutely. Absolutely, right. That's what I was talking about earlier. When we look at assembly lines, right? They have sophisticated tools that needs to connect to some system to get an authentication that this particular user is allowed to use this tool. But it's a very precision heavy tool to make sure when you're drilling these many centimeters or whatever millimeters. And it translates that data, sends that data back to so they're tracking everything now. Right.
And their own data.
Right.
Not coordinating the data from all the information from the centrally, doing an inference and then managing that. So I guess there is also another dimension.
It is.
Collect the data from everywhere, centrally.
Exactly. Right. So that's why I was saying that the data ops platforms that many of these industries are starting to use are collecting more and more data. And that data is connecting over wireless networks. If I have to, you won't believe, if you go to some of these manufacturing facilities, they're actually going in and actually still using paper to collect data. They go back to their office and they punch that data in. Just getting the connectivity using a tablet with those, that's the first level of when they talk about digitalization. I mean, you said it right. That's the first level of digitalization for workflow automation, right? If I go into a factory floor and I have 20 machines to do this, and my tablet doesn't work, then what, right? This is plain and simple, first level, right? Second is, okay, I have more sensors, predictive diagnostic, the machines are sending data. Third is, with the tools I'm using is sending data. All that data, if I start to always, bring in wires into this, it's a nightmare. Guess what? 6 months later, I have to change that layout. That assembly line is no longer the way it was because I'm now manufacturing something else. That's flexible manufacturing. So wireless, because of that reason, is very, very, very important. And again, there are areas where Wi-Fi will work, there are areas where cellular makes a lot more sense in connecting those things. And in those examples where they're already wireless, there are CPE devices where you can actually connect existing systems wireless. Harpreet is going to talk about how they did it.
Really along there. And this is and this defect that it has to go to where you can send you things like microseconds. And then it's going to have to go back and then the what have to be struck is going to be this way. You have to take out the defective part from the lesson. That is so latency.
Yeah, very latency sensitive. Absolutely.
Because of we are in this intense control.
Of course. But again, my point is don't use the word ultra low latency. It's about your response time. Can you afford 3 seconds of delay in your tool getting an authentication that you can use it? What does that do to your business, Mr. Customer? Right? It's again, I need to be connected. I need to be connected real time. I cannot have any level of downtime. Not downtime doesn't mean that my network is completely down. That the downtime means I can't operate. I'm waiting, when we open our laptops, it takes, we get, we live in a world of instant gratification where, we do something and we want result right away. Right? When we starting logging in, and there was a time when it was okay for us to wait for, 20 seconds for the laptop to boot up, right? And then now it's like, if it doesn't, we get anxious about it, right? These guys are on the floor doing their job and they're waiting. Oh, I don't get, well, I am still waiting. Can I use this? Can I use this? Can I use this? Right? You need to give them that picture. Can you afford it? No, if you can't afford it, here's a technology that can actually deliver you that.
But your point is very well taken. There's a diversity of the interface. There's a consolidation that needs to happen over the years, not today. So how do you facilitate that translation and consolidation? And then there are certain aspects of the network, as Ashish was very likely saying, critical for operation of certain components of the network and certain components of your DSPs and carriage and whatever it is that you're doing. How do you prioritize that? How do you manage that in a deterministic fashion? And one of the things that they want to interrupt Ashish for, one of the biggest challenges that we saw when we first did our first factory deployment was people were just duplicating the SIM by mistake. That's by mistake. But they were connecting undesirable devices onto the OT network. And the IP pool addressing, apology for the weakness over here. That's what I'm saying by the way, DC. So, because of that IP pool addressing issues, there was issues around industrial espionage and so on and so forth. So but for every challenge, there is a solution, or there's a path to the solution, and that's what I think Ashish is trying to hit at, right? So let's figure that out together.
Figure that out. I think that's a conversation, right? I mean, honestly, all of a sudden, right? Why is cellular even relevant? I mean, why are we talking about cellular? Is not a new technology. It's been there forever, right? We've used it. Why all of a sudden cellular is now attractive and important and even viable for enterprises? I think that's how we need to also look at. A lot of people still think when we say cellular, they still think Verizon's network or AT&T's network. Oh, how is that gonna help me? I'm not gonna use it, right? That mindset of cellular has to change. And there are three things that we need to articulate. Again, spectrum was always in hands of limited entities who could provide that. That spectrum is opening up. We have Kurt talking later today from Ongo Alliance. They're going to talk about CBRS, how that has opened up. To be honest, I mean there are a lot more spectrum being available now for private use, and it's going to be more and more. And depending on which country you go to, if you look at a graph of where the private network adoption is rising, it's everywhere the spectrum is being readily available for the enterprises to use. I mean, Europe is opened up, they're giving away spectrum. I mean, you don't even have to spend any money to get that spectrum. I mean, you're getting it for $500, $1,000 for enterprise use. And I'm not talking about like lab licenses. I'm talking about commercial licenses for enterprises to use it. So it is happening. Netherlands has done it. UK is starting to open up something similar for on-go lines, the CBRS model, the shared spectrum infrastructure. There's more and more of that spectrum availability is there. There are other spectrum opening up. I mean, I have Murat from Globalstar here. Talk to him. I mean, they're opening up N53 band for commercial use, right? So that spectrum availability has become more easily accessible for businesses to use. So that has really taken away that barrier to entry for many people to serve this market, right? The enterprise readiness is there. I would say the use cases are there. The ecosystem is growing. Somebody asked about devices. I think there are a lot more devices. I think there are a lot more applications out there. I think the infrastructure that we have a mindset of towers is not needed for enterprise deployments. That infrastructure is shrinking. They're shrinking in a box. I've seen a lunchbox like this size with an entire private network. So that is happening. That infrastructure is shrinking. The IT/OT integration is being figured out in terms of newer management applications that are being offered in the market. So I think the enterprises need to be brought to that knowledge level and say this is not rocket science anymore. You don't need that big tower. Right? That education is needed. And the cost economies, as I said earlier, right? There are cost economies. I mean, I put this together just to give you an example, right? I mean, in terms of if you look at Wi-Fi deployments today, I mean, there are, of course, every Wi-Fi access point needs a cabling. It's a site to be configured, and the cost parameters of cellular, when we start looking at the coverage it provides, the bandwidth it provides, and the number of APs that are required for cellular, are at the end of the day, from a cost perspective, it's going to become comparable. I'm not going to say it has gone down than Wi-Fi, but at the end of the day, the idea here is not going and replacing your Wi-Fi. It's giving you a network that you can segment to serve different use cases. You do still want your Wi-Fi because at the end of the day, how do they measure the cost of network? Cost per bit. What's the cost per bit of transferring data from point A to point B? For some applications, you can actually afford to pay more. For other applications, you want to pay less. And you have to intelligently decide what is the right network for which application. All right. I'll quickly run through this. 5G brings new capability. I'm not going to go on the left-hand side. There's a lot of marketing BS on this in terms of number of devices, internet, and all that. But I think what excites me about 5G is really the programmability aspect to it. It's how the network is becoming programmable, how it is exposing the APIs, not only for the purpose of configuration and management, but also real actual interaction with the network, and how you can authenticate the user, how you can influence the quality of the network, how you can preserve the resources, and many other things. And Harpreet is going to talk about some of that later today. All right. I told you earlier, a lot of that is happening. It's happening in airports, it's happening in warehouses, it's happening in manufacturing. And without taking too much thunder from Jason and Kurt and Harpreet, I'm going to let them actually showcase you where things are happening. And by the way, many of you I spoke with, you've already seen those deployments. So please feel free to share your examples. And it's happening not just in manufacturing, it's happening in transportation, higher education, smart cities, healthcare, warehouses, agriculture, every industry. Every industry has seen a deployment of private network. We regularly track that data. So if anybody wants to see that, let me know. Okay, with that, I am going to end my presentation because I've already taken a lot more than I planned. Just want to say, this is again, our mission is to really serve the market. For anybody who's trying to get in this market, trying to understand how do you go pitch this, these are the kind of content we'll do. Playbooks for SIs, right? Playbooks for SIs, content for how do you ask questions, how do you navigate. We're going to build a lot of these small videos. Anybody who is interested to contribute to that kind of a content, let us know. Great. Jason? We have Jason from Revels, who is a go-to-market partner for LG Electronics. And we'll have Jason talk about what they do and then how LG is benefiting from it. Thank you.
Thank you, Ashish. Thank you, Tim. You guys do have a lot of expertise, and I appreciate you educating the market on private wireless. It's important. It's important to a lot of businesses, and I'll address some of the things we have here today. Oh, let me go back to this original slide. So I'm going to spend most of the time on the case study. I'm going to probably skip through quickly the first few slides. I just want to note, representing LG today, I didn't realize this, but they are the third global 5G patents, and that's above Nokia, it's above Ericsson. So it's only second to, of course, Qualcomm and Huawei, right? So they're an interesting manufacturer. So the reason why I'm here is Revels evaluates and looks at many different manufacturers so we can bring the most innovative solutions to our partners and network operators like Betacom up there, and to make sure that their use cases they're dealing with in their deployments can be met, right? It's not one size fits all typically in a private wireless network. Just a little bit, this is really less important than the use case, I think, or the case study. But essentially, LG, what they want to show here is that they're not one size fits all. They have a component approach for very large networks, and they have a kind of an all-in-one solution for smaller networks. And they're very good at user interface, as you would imagine, right? They're focused heavily on the enterprise. That's where their robots are, that's where their displays are, that's where everything they make lives. And so for the past 4 years or so, they've been building their own private wireless network, deploying it in Korea and perfecting it there. And the case study today we'll talk about is here in the US and a smart factory. This is just a quick look at their UI. We can talk more about that later, but I think the really important thing is this case study. I think it's what you want to hear about. In fact, it's in Tennessee, and to give you a little background, the question you brought about Wi-Fi, Wi-Fi is a complementary technology. It's not a replacement for, right? So there's too many devices on Wi-Fi, and you often you have use cases that are really not designed for Wi-Fi, but they need to be wireless, right? So many use cases and applications and business functions are being put on Wi-Fi because it wasn't really another alternative. And when it comes to really mission critical business applications that cost millions per minute or second, you have to begin to evaluate some other operations. So this is one of the first lighthouse factories in home appliance industry. And Lighthouse Factory, if you're not aware, it's the World Economic Forum designates it as an advanced technology in digital transformation manufacturer. Right, so this is a designation in the industry, and so this factory outputs approximately just under 2 million units a year. It's 70% automated now. Originally, this was designed using their Wi-Fi system. They redesigned the Wi-Fi system to accommodate the AMRs. There's about 150 of them. And they had some challenges. It was only for the AMRs. And of course, AMRs are autonomous, right? They're not like AGBs. They both transport stuff, but the AMRs are more flexible for manufacturing environments, as you don't have to put tape on the floor and electronics and wires to make them guide all over the place. So AMRs are important to them, so that's what they focused on initially. And so when it didn't work out the way they wanted, they moved it to a private wireless. And now I'm not going to tell you the private wireless installation went fantastic out of the gate. In fact, that's where we kind of came in later. So they partnered with an existing integrator to install it. And when the system was up and running, it didn't work really as planned. And we're going to talk about that and the steps we did to kind of correct the network, if you will. Because a lot goes into designing these networks. But you can see these particular, it hit a logistics to manufacturing specific use cases. And you'll see the little green boxes, these little modems right here. These are N48 modems. There's a couple of varieties of these on the AMRs. They're all this particular model, internal antennas, and there's some with external antennas. It looks exactly like this, just has 4 external antennas on it, right? So that is able to go inside a little antenna on the outside, right? So everything was outfitted with an M48 device, and you want to pass it on. To your point, there's not a lot of devices out there, and this is all 5G standalone. This is not 4G. This is a 5G standalone network. All the LG networks are 5G standalone, and there's a lot of benefits that come along with that. So we found it pretty interesting that they found it pretty interesting that we could address a lot more use cases, right, with a private 5G cellular network than you could with Wi-Fi. And now it's 70% automated, the entire factory. So, so there's a lot of reasons to migrate to a 5G network, because Wi-Fi is not one size fits all either, right? In a manufacturing environment, that deterministic traffic that you spoke about, and certainly the weaknesses of Wi-Fi get exposed in certain environments. The ability not just to have the AMRs and the robot arms and all that connected, but using those AGV glasses and building software that goes along, digital twin software, that augmented reality guidance as they fix equipment. These are not just things you've heard about them, but they're implemented here, right? And I think it goes a long way of saying, hey, private 5G is a good conversation point, but it's arrived, but it's taken a lot of work. I'll just say that. So this is a really basic, high-level design of this network, but essentially it's a manufacturing facility, right? So you have a dual core, you have dual RAN, right? They wanted that level of redundancy because it cost them a lot of money to lose that uptime that you guys all spoke about, right? So that's how it's designed. There's roughly 350 devices covering 800 square feet. Just for there's 91 APs that were covering that same space, and it's roughly less than half that of the radios that are required for private cellular. So I'll talk a little bit about how that impacts things a little later. But it's been quite a journey, right? It was implementing it, and again, the AGVs were only on Wi-Fi. But then when they started moving to private wireless, it took them on a little bit of a journey. It took, because it wasn't it had to be installed with care. There's a lot of everything from the physical layer all the way to the spectrum and how they used it, how they interacted with the SAS. Everything was important, not just these little devices that are getting passed around. Like that's the candy. Everybody wants to touch those, right? But there's a lot of work that goes into making a high-performing 5G cellular network. And I've worked with a lot of you. I've worked for some of you, and we've been through a lot of this. But so we had to resolve some issues. There was cabling, physical layer issues, right? There was SAS issues, spectrum reassignment. There was SINR issues, right? There's issues that you have to deal with in RF, just like a cellular network does, right? And once it's optimized the way it should be, you'll see that the performance right ahead of you. So let's just go into something really basic. Okay. Just power and Ethernet cables don't go together. But these are things that we all know. But when you choose someone to do the integration, network operator to work with you, you really have to choose well, because it's not just physical cable plant that's getting laid. Someone has to be paying attention to the shielding, to the separation, just to ensure that all the standards and best practices are met. It sounds very rudimentary, but choosing the right partner is important to do that implementation. That was one thing that had to be rectified. The next thing is the SAS hierarchy. Everybody knows that there has to be constant communication, right, between the CBSD and the SAS. So in this case, the timer on the equipment was set for 4 seconds. change that to 6 hours and work with the SaaS provider to make sure that, the disconnections or the hiccups that were happening in the initial proof of concept didn't happen again. Right? And then spectrum reassignment. I mean, it seems very straightforward, right? Don't use channels that are consumed with interference. But if you're not choosing a partner that's familiar with private wireless, familiar with working with SaaS, and familiar with working with CBRS, you're going to have these issues, right? And so things are moved around and cleaned up from because noise, obviously, uplink is your biggest issue, generally speaking, in an indoor environment. And it was here too. The spectrum reassignment was finally done. And then we move on to, okay, now that all these basic, I'll call them level 1 issues are fixed, let's go take a look at something more important. Let's go look at the RF around and see, what's going on, and see if it's designed properly just from a planning perspective. And found that there was a couple of radios that could be turned off, and those radios being turned off improve the performance of the network. I know Kurt's experienced this lifetime as well. Turning off radios improves performance. Sounds counterintuitive, but it's what needed to happen. And then you start going through prioritization. Everyone talks about QoS, we call them QCIs, right? Mobility. So you want to make sure that what this network was designed for has priority and is also as assigned to a specific spectrum so that it can always be running and active the way you want it to be. And stuff like software upgrades, that should be moved off as a low priority on the frequency that certainly that it's running, that the AGVs are running on and off to. So all these little things added up to huge improvements. 10% increase in downlink, 50% increase in uplink, 50% reduction in latency. And so these things were, I'm going through them quickly, but they took months to really sort through. You didn't think there was physical layer issues, and cabling and power. So, and these are just some technology comparisons. When you compare Wi-Fi and private 5G, one's not a replacement for the other. You still need Wi-Fi, but there's places where, Wi-Fi's there's only 240, less than 300 megahertz of spectrum, but it's all full now. It's not just your printers on it anymore. It's everything that you have is on Wi-Fi. Right? So there's a lot of, and it's a contention-based protocol, so a lot of noise. And on top of that, you require a lot of APs, 4,000, some big number earlier. And all those, they have overlap, right? In those overlap areas, the sector boundaries create more noise. And then you go into a private wireless or private 5G, and you can really reduce on some basic level those at a minimum. And there's other techniques. We'll be doing other improvements to this factory later on where, given the channel sizes and the throughput they require, they might not even need that many sectors. You can make it so that those radios are all, from an O-RAN perspective, everybody's front hole, MUX understands what that is in O-RAN, so that you can have multiple radios acting as one sector in line with the O-RAN Alliance architecture. So there's lots of things you can do with private cellular that just can't do with Wi-Fi. And there was a lot of, I think this is the most interesting, when you compare the AMRs in particular, and the robotic arms and other aspects that they had, but mostly all this data is from the AMRs only, because originally this was only the AMRs over Wi-Fi. I'll go back to all the other use cases. I want to circle back to all the other use cases that were added once they put private 5G in. But private 5G moved it from hundreds of reconnections to 0. Those are just the statistics. Those are the KPIs. And because Wi-Fi wasn't meant for an automated robot to navigate independently throughout the factory.
You turn that into dollars?
Yes, all this is dollars.
No, but I mean, what's the dollar difference between the success and the failure?
Oh, how much did that cost them?
Yeah.
I don't have that number. I wish I did. I didn't, we just went in there, fixed it. So, but yes, but it was massive. It was massive and allowed them to go.
Right. And the bigger the number, the better the case. That's what I was asking.
Right. And then,
This is very typical, right?
correct.
Yeah.
But the mobility piece of the private 5G, right, rather than the Wi-Fi, right? And your connectivity and interactiveness, right? The pieces that are affecting you, right?
The private 5G is not a magic pill. You know, and I think going through that case study, would just recommend choosing the right integration partner. It's whatever manufacturer you use, if they're fixing your problems, great, but it has to be installed at a level of best practice. Otherwise, it's not going to perform the way you want to. And what's interesting is this lighthouse factory, is why it's a lighthouse now, is because it went from just the AMRs to now 70% of the factory has automation. And all this is over the private 5G. All these devices, from logistics to remote monitoring, the operational efficiencies, all the things we talked about here are implemented in Tennessee, and they're working. I think it's fantastic. LG actually happens to have smart factories and such over in Korea, but no one likes to talk about foreign deployments. But they're much more advanced, right? They have their own robots. They have all kinds. They have really tight integration. And the challenge of getting, I don't know if anyone else here has challenges of getting those little devices, but N48 5G devices are not so easy. But I guess when you're used to understanding how to make UEs and things like that, you get very resourceful in making what you need to solve use cases. So we're going to make it.
Quick question on your manufacturing specific to the wireless PLC. Was that a wireless PLC or is that a virtual PLC?
It's a virtual PLC.
The fact that it's an integrator.
Sure.
Flip side of that too, is you need to make sure the system integrator can use that practice. To make sure when the system integrator is coded, to use that's best practice, because it's always a problem.
Someone's got to manage that.
Otherwise,
Who's managing the construction? Yeah. It's all good on PowerPoint slides, until you get there, but it just, private 5G is really changed listen, it's not meant for, in my opinion, it's not public use. This is for operational efficiency for businesses, flat out, right?
That obviously reduce power. Compared with Wi-Fi and even 5G radio. You have the like 1 to 4 to 5. I think that our deployment was the 1 to 7 or
Yeah.
8.
Yeah, it can be.
Still okay. Right?
Yeah, oh, yeah.
So in that case, you save even more for deployment.
Yes.
Because for each Wi-Fi deployment, normally takes $1,200 for each Wi-Fi deployment.
Right.
Normally can.
Right.
And then if you use the private 5G, we do have you have 1 to 7, 1 to 6. That's the
I agree. That's generally the ratio. Again, but yes, I agree. It's a lot of cost.
Originally, I think it was 1 to 7.
Yeah, and it's very cost efficient compared to Wi-Fi. But I don't think it's not one or the other.
Yeah, up to a 1 to 20 deployment on these cases, or one of the customers that we talked about earlier. Or in-house use cases down to 1 to 6, 1 to 7, which would depend on the price of that manufacturer's radio, right?
Yeah, and you're balancing capacity versus coverage. Right? How much capacity, because you can have one radio cover a large space, right? But they're sharing that sector capacity. So if you need more capacity, you have to introduce more radios. It really depends on the use cases you're deploying. If you just need least most amount of coverage, least amount of radios, you'd probably go to 1 to 20 for sure. But as that use case changes, you can add radios and add more capacity.
And then I see the use of the environment. Like, are they speaking?
Yes.
Directly from the device?
Yes.
That's what we can chat with the 50. They will create a network. They have a lot of defense from the PLC technology, but they the PLC sort of yes. As you can call it, just speak data, all these PLCs are local connection wireless.
Yeah.
Are they starting to use 5G or is this?
Yes. Yes. It's changed a lot since these slides, and again, we'll have more modifications later this year. Later this year, they plan on grading them even more, just to become more efficient in the network. But,
There's a huge amount of manufacturers that have 6 or 8 different connectivity points, including Ethernet. Yes, all of the PLC call after input. Really put, taking pressure pretty hard.
and listen, I'm here all day, and thank you. I'm trying to go,
A quick question.
yeah, of course.
On the Wi-Fi stuff that we have talked about so far, it's a traditional Wi-Fi, 2.4, 5 gig connectivity, right? That went that way with the other. Do you see any difference?
Do I see? It wasn't deployed here.
Backflow, it's a cleaner spectrum, it's a much more higher frequency. The drop rate is very, very lower compared to.
You're adding,
the cost is lower.
you're adding frequency to Wi-Fi, right?
Well, it's completely different standard. It's literally there are no devices right now which can connect, but other than the modem and so forth. But
Sure.
the issue that we are running into with one of our customers is they did an analysis on the 6 gigahertz, and they're trying to compare it with CBRS or with in Europe and 77 and 78 and 48, whatever it is, and they're working with. The dirty spectrum issue that we had in batteries, the 2.4 and 5.1 is gone, right?
Sure.
It's a cleaner spectrum, much more capacity, not just support for USBRP and everything else for QoS management, device security, and so forth.
Right.
How do we, have we run into that packet loss scenario or CAT NG?
Versus,
6 gigahertz Wi-Fi versus 5G?
no, because essentially that deterministic traffic or the mobile traffic that you're requiring for, and it goes beyond that. It goes, meaning the software that is being built for a lot of manufacturers, not just allocating, and all these Docker containers, and then you have to introduce like a kind of an artificial intelligence firewall. You have to make that software secure, right? So it's more than just the speeds and the feeds of the network. It's the use cases that are driving. If Wi-Fi 6 or whatever, the 6 gigahertz works great. I'm sure some of them use that, but it has to, whatever the buckets are that are important to a customer in manufacturing, not just whether it's speed, whatever use case it is, whether it's mobility, whether it's security, whether you need a NIST certified software platform to put this in your network, whatever that is going to determine the outcome. It's not just a box, right? It can't just be, I want to use Cisco or I want to use, you have to find a solution that works for your business. It's the only way, and it's complex. LG doesn't go and compare itself to those types of technologies. When you develop software, do digital twin, so you can wear AR glasses, right? And have some augmented reality guidance on a system. That's the kind of problems we're looking to solve, right? We're not looking to solve who's, maybe a little faster or slower.
How does the basis software or how does it try to just react to that tracking that getting like 206 packet drops or DG and
See,
right? And I was saying, well, we have done similar studies with Wi-Fi 6, E, and 7. Those numbers are no longer valid from that perspective because the reconnects are actually much better in Wi-Fi 6E, 7.
sure.
And so support that the modems are much more easier available for Wi-Fi devices for Wi-Fi. So how do we, it comes back to what Ashish's talking about, right? We are going to sell them. I know it's not the case in LG, something that we're using their own doggy food, right? Dog food as well. But in case of people like us, but we are trying to convince the customer, hey, 5G cellular network is better. But at the same time, they throw these things because it's not a problem, because we don't have a problem statement for them, just like what I keep said. What they're trying to figure out is how are they going to reduce my ROI? how am I going to beat my refresh cycle of probably 5 to 7 a year and become a little bit more future-proof? How do I bring my cost of investment of network lower and lower? How do I make my applications more, independent
Sure.
and moving towards the edge, that kind of stuff, right? So that's where, my brain was going when I looked at this challenge, like, all right,
Yeah.
if that's a technical chart, I can understand why my OT guy in a plant manager is going to come and that. I can get him with 60 by 7 right now,
Right.
right?
Right, sure. I mean, it depends what they can tolerate for drops. Half that wouldn't be tolerated. Like even these numbers that even half that wouldn't be tolerated at this factory, right? So it really depends on what the use case requires, what the customer requires, what they're willing to live with, how many minutes of downtime they're willing to live with. And I think I think those questions I'm sure existed, certainly at the beginning of this. But by the end, when they went from just the AMR to all the robot arms to everything else that was connected, they just had a different perspective. It was an easy button. It was no worry. It wasn't if it was going to work or how many drops I might have or how better the spectrum might be. There was more guarantees. And they were able to deploy with a lot more confidence at the end of the day. Because I agree with you. I think those questions, they're brutal.
So that's the SIs and GSIs over there. We need to be ready to ask them those questions.
Yeah, sure.
Like that, they're being ready.
I agree. I think I talked to engineering companies yesterday. I participated in 4 months, right?
Yeah.
Working around. I talked to maybe 20 plus or something. And what they said is that they try to overcome the cost of development to compensate this drop. Yeah, right. So instead of replacing with private government, I agree. If you only talk about technical issues, they may be able to overcome one way or another. And I think the key issue, I feel, is the device is not there. So you have to tell them, okay, you can have dual mode, you can put 5G module in there, but now $100 for AEV cost maybe $20. Right? So I think this is, I don't think it's missing. It's something we need to promote more.
Yeah, you got to understand their business. And
At the beginning, that device is key.
There's something like a case right now saying, hey, how can we educate the market?
Yeah.
I think this is someone is
It's a very relevant question, right? Again, if Wi-Fi is becoming an EMP, then
I have a question. On that chart that you had up, drawn. Did y'all do, people did figure out those sort of complex problems?
on the Wi-Fi side?
Yeah. Yeah. One of my side, there was a good interference with.
Yeah, so when it came, when private 5G was introduced, before that, this was designed, so you designed the factory for the latest Wi-Fi and optimized it. And so the challenges they came with the mobility, when these autonomous robots are not on track paths, right? So you couldn't predict literally all the time, they're autonomous. And so there's just a lot of cost and difference. You know, those auto coverage and inter coverage were second rate overlay. It's great.
So the hand.
So, yeah, the lion's share of it, exactly. I don't know all the details because I know they spent millions trying to fix the Wi-Fi and optimize that network and best visibility. And then they ran out of options. They had a lot of pretty good people in the Wi-Fi network. Wi-Fi is a great technology, not designed for all the other technology. You know,
Part of overcome the physics, if you've got 4,000 access points in a small location.
Right.
So we can figure out how to reduce the number of access points in that location and still have robust coverage. That helps us solve the problem.
I think a point that's not made enough is that inherent to cellular is handoffs are built in. It's not inherently more. You're gonna get mobility out of private cellular. You're never gonna get.
You couldn't call that or do
correct.
As a deputy, I agree with you. but I actually have practiced in mesh Wi-Fi on phone before, right? And I also offer a couple of 802.11 tech system here, but I really appreciate that. The issue which I think we are trying to still struggle with, how do I tell that to my OT manager? That, who's the final decision maker?
The way that I demonstrated to non-techie people is I related to a regular cell. So if you establish a call, you're driving in your car, you're connected to tower A, you're driving down the highway, your call gets connected to tower B. And when you walk off the tower A coverage, you're now using tower B. Did you know that handoff happens? No. Your audio was great the entire time, right?
The only cover I have right on this is I actually put a shipment expresses Wi-Fi system on behalf of Cisco. If you ever gone from Tokyo to Kyoto, taking the shipment express, we actually did five AP handovers at 350 miles an hour, and you did not see a packet run. It's an ensuring activity. I completely give you that, and I've been a geek of 3GPP from very, very beginning. I've actually the initial contributor to R4 right, on 3GPP. So I completely recognize that. What I'm trying to get at is there is an inherent problem that we need to solve about communicating and educating the market about benefit of 5G and LTE, or even smartphone, I love those protocols, by the way, and so on and so forth, on how we can actually solve a business or an operational problem, right? And then go from there. Because I'm so sorry, I didn't want to interject with all of this. When I first presented some of these kind of statistics about my customer in 2021, we were doing a 5,000 sensor, 26 AGV, 128 camera deployment in Pennsylvania. When we were doing that kind of a work, it was all about other things. I can actually solve everything with 6 because my IT geek tells me that I can actually do that. And it became,
What did that from, right? Have you done it?
actually, but the problem is not as FI and platform provider. It just comes down to, it's like going to a court of law. It's like one expert versus another expert giving the data, right? And so it's like, is my expert better than your expert? So Cisco's and Arubas and Extreme Networks and those guys, they just stand up and say, no, we can fix this. And then you come to us and you go, no, they cannot fix it. Just because he said, she said, What we're trying to mitigate somehow is no, this is definitive, right? There is an inherent value with 5G here. And this results in, like you said, reduction of 4,000 APs to maybe 2 cell sites, 2 RUs, like maybe 3 RUs with 1 CUDU at the back. That itself is a cost benefit and the connectivity benefit and so on and so forth that we can build a story around and then go from there, right? But that's what we're struggling a bit and how to penetrate the manufacturing.
And the additional capacity you receive. Additional capacity is going to be needed. That 6 gigahertz is going to be needed down the road and private wireless. There's only so much frequency to work with. So why not? Mitigate your.
It is not.
Yeah. I know I could get up there.
And I think we have a hard time right now, but that's people going to the time for that.
I don't hear all that.
Thank you very much.
All right. Right. Good morning. I'll do this in a rapid fashion, slow me down and engage. I am Kirk Jacobs. I am the vice chair for the OnGo Alliance, formerly known as the CBRS Alliance. Which is the spectrum that is available for shared use in private networks. Talk about that. I have a day job. I head up our federal markets for JMA Wireless, which is a RAN company based out of Syracuse, New York. We sell equipment into the private wireless space and have numerous deployments. So I'll bring in some of that expertise here as well. But I'm primarily here for OnGo Alliance. That's the shirt. I didn't wear the hat. I'm going to talk a little bit about the OnGo Alliance. I'm going to talk about spectrum is really the real estate, to use a building analogy, in which you first have to get the zoning right and understand. Then you get into the use cases is really the foundation of the building. Have to understand, talked a little bit about that earlier today. And then the operational value. Why are you building it? And I'll give some examples here. I put at the bottom here, I think there was a pivotal moment, inflection point in the industry, not directly related to private wireless, but adjacent, in that Verizon, Super Bowl is always the most intense wireless event ever, right? It's all upload. Everybody's there. They're really competing it. There's people in this room that did a lot of solutions there. Verizon, even though they have all this spectrum, used to try to push people to Wi-Fi to have a better experience. Well, that didn't happen this year. Wi-Fi, they found in the last couple of years, was not performing as well. Private wireless systems, including private, is so deterministic and can operate at scale now, such that they were pushing their users, tens of thousands in a bowl, to move to cellular. So that, I think, is really foretelling that 5G and the capabilities are progressing there. OnGo Alliance started as CBRS Alliance. CBRS Shared Spectrum is a U.S. innovation and is really being looked at as a model for the rest of the world. It is mid 3 gigahertz, so it sits between the two Wi-Fi bands, so 2.4 and 5 gigahertz. It really started as, well over a decade, 15 years ago. It didn't go to commercial deployment until right before COVID, in 2000. So it has been active less than 5 years. And so when initial commercial deployments just before 2000, it survived COVID, went to full commercial service. They auctioned off, so it's a tiered thing. So there's some people that have priority access, the MNOs and cable providers primarily, some private folks like John Deere and Southern California Power. And there was a bunch of users that had to switch over that were using it, the wireless internet service providers. You'll see that in a second. Private wireless was a little slow because the ecosystem wasn't there with all the devices, all the equipment. We didn't figure out how to implement it. That is starting to change. And we're about 100 companies and really driving it. Now, initially, it was very much a technical exercise, and nobody would even know if this would work, right? Well, it does work. And that has improved. You will see the OnGo Alliance actually shift our focus over the next year. I can't say what the announcements are, but less on the technical and more on the promotion. And I would say in the US, we kind of are the de facto private wireless alliance, if you will, right now, because spectrum is the real estate on which we can build this. We're not the only user for private wireless, but the system can support multiple users. So there are around 400,000 and growing broadcasting devices, access points, whether they're on macro towers or in building. There are almost 1,000 devices that are FCC registered to be UVs that support 4G or 5G CBRS. There's over 5,000 people that are registered to be able to kind of notarize the location for the access points. It is 5G ready and there's deployments. Jason was just talking about some of those. And there are well over 1,000 different organizations using the spectrum, all the way from Verizon, all the way down to 2 Men and a Dog that are using it. So very, very diverse. It's a choice in an enterprise. What are you going to use to connect? I will argue that the number one use case as substitute is wires, not Wi-Fi. It is wires, not Wi-Fi. Wi-Fi is complementary, as said before. It is replacing wires and introducing mobility in the support of the digital transformation. For all the reasons that were just talked about, it is the HOV lane of spectrum, okay, versus the congestion you get with Wi-Fi. Works great, nobody's on the road. And it's not the dedicated isolated bus line that you can't use, which would be commercial or licensed spectrum. Where we're at, NTIA, which is part of the Department of Commerce, they run federal spectrum. They're kind of the arch enemy of the FCC. Actually ran a report as of July of 2024. This is part of some of the changes I'll talk about in a second. You can see that the growth from 2021, which there was a bunch of users that had to move over automatically that were grandfathered, that had to switch from Part 90 to Part 96. That's FCC talk. The growth has been pretty linear and consistent. I mean, that is a very, very straight line. Now, there's been a couple phases. There was they had the PAL auction, so people that were using it like Verizon for were lighting up systems. There were additional wireless internet rural providers. But what's also happening now, and a lot of this was outdoor deployment. What's a little harder to see is the blue line here. These are category B high power. Now, power levels indoor, outdoor are not necessarily the same thing, but they're pretty closely related. The Cat A, which is mostly indoor, lower power, was pretty small. I mean, there wasn't much. It was less than 1% in 4 years ago. Today, it is growing, and it is the fastest growing part. While there's still a lot of outdoor, that is not growing as fast. And I'm showing here just roughly the indoor or the lower power is growing at about 15x rate versus a 3x rate on the outside. So this is the area where private networks are starting to grow. And the fact that that spectrum is there is also driving it. So we expect this red little blip to continue to grow and take up a larger percentage of all the CBSDs over time. When CBRS originally came out, nobody would know it would work. We didn't know how it would interact with the Navy radar that was on the ships. We didn't know that there was actually some inland sites that were using the spectrum. And it was extremely conservative. I mean, like ridiculous conservative. 4 years after operation, not a single interference event. In fact, they tried to detect it. They tried to create interference with the incumbents we were trying to protect. They couldn't do it. The noise level was too high. So last year, through the OnGo, a lot of pushing from the OnGo Alliance and working with NTIA, it's a great part about sharing. We actually could agree and adapt and modify. We moved the areas where Navy radars or you heard all the FUD about, oh, I'm going to be thrown off and I'm not going to be able to use it. Well, first of all, it's only 10 megahertz at a time, not the whole 150. But they brought that back, particularly for in building, such that, as we say, your feet basically have to be in seawater before you're going to be subjected to an incumbent event. So we went from almost half the population being in a dynamic protection area to now it's less than 9% of the population could actually even have an event. So that made the spectrum a lot more reliable and predictable, particularly on the coastal areas. And some of the inland areas, because that were near some population centers. The other thing, and Jason talked a little bit about that, was they changed the heartbeat when you from 5 minutes up to 24 hours. Now, in reality, most people are doing like 6 hours, but that's you didn't have to maintain that connection to the spectrum access system. So yeah, this is great news for private wireless, and we believe will drive more of that. So switching to private wireless, there are 6 elements that make up a private wireless system. Most important is the applications and use cases. There has to be a reason for it. The second most important part, I say, is the system integrator and the service provider that put it together. The easy part is the technology solution, which is, well, what am I going to use for a core? What am I going to use? Who am I going to connect to for my spectrum access permission that's required? What devices? As I said, there's almost 1,000. And then the radio access network, which I have divided up here into 3 types. You have your high power ones are going to do for wireless internet service providers, or Verizon might put on a tower to do their augmentation using CBRS. They don't use all the spectrum, they only use a part of it. So depending on your use case, you might choose that. You might do access points, which are small, probably limited connection. They operate independently. Small chipset-based small cells, or you can do a more multi-service distributed radio system. So you have choice in what radio access network you're applying as well. So not all RANs are created equal. So we can talk more about that offline if you want to. And you know, Wi-Fi is good in carpeted areas, as we say, and predictable. I'm using it on my screen right now. Cellular is very good when you get far away. Private wireless really has the option. And the other part is it is the technology, because it's new and it came out to support it in the 2000. It is already cloud native, IT infrastructure native. So an enterprise CIO can now understand what I'm getting. It used to be proprietary mobile equipment, the stuff that sat in the shack at the bottom of the radio tower. Nobody knew how it worked. If you did a DAS system in the stadium, it had separate rooms, separate power, separate key entry to get in there. That has all gone away. It is now becoming the solution. The technology is moving towards the sound of the gunfire for the CIOs. So that is one of the key motivators. I'll skip over that. We hit Ashish hit a lot of these points on why it's important and why a private network supports industry digital transformation. Okay, now I'm going to switch over to the vertical use cases. Yes, yes, sir.
Yeah. With different use cases. Do you see some of these emerging OEMs coming in, helping changing dynamics, making the market bigger because there's more affordable?
OEMs on the equipment,
Yeah.
In the providing stuff here.
Yeah, would it be,
Yes. I wasn't going to talk a lot about it, but Open RAN and ORAN, the ability, and there's a lot of investment in the U.S. to drive more U.S. telecom supply chain. That interoperability and mix and match is happening. I will say the private wireless networks and CBRS, OnGo, is helping drive that because it's driving into verticals. Verticals require differentiation and I've had federal, mission tailored, or you could say industry use case specific. That's driving those unique solutions. And Ericsson, Nokia, 99.9% of their thought and brain and energy, great companies, but they're trying to figure out how to put radios on towers.
right.
So the folks that are doing the in-building is an exception, not the rule for them, where other U.S. innovation can grow in these vertical expertise. In fact, the NTIA has this NOFO funding out right now to actually drive software solutions for verticals using Open RAN private networks. They're putting $450 million out for contract. Let's hope it survives Doge. In order to help move that along. Yeah, that's yes.
Important aspect is talking about Wi-Fi versus private 5G, the ecosystem, native connectivity built into private 5G space. Like, Ongo registered FCC somewhere around 1,000 devices. Relative to Wi-Fi, it's small. Next private 5G natively on your laptop, we not. So one of the things in our industry that's cost factors and the adoption factors, if you next go to an APD device in the factory that have native private 5G in it. Not likely, not today. But as Jason showed, we need an adapter. That piece of the market, that edge device, connectivity is a big piece of what we have to.
Yeah, and if you're recording this, then here there was a discussion about devices between the ubiquity of Wi-Fi versus cellular, which agree it's still growing. But it's also why the system integrators and providers add value to this to solve that. So you don't need 100,000 ways to connect. 1,000 should be good enough, but you can help provide that steer to those right devices. Okay. Ongo Alliance. We have put a lot of effort with our partners and member companies and even non-member companies to say, bring us your industrial use cases. And I have listed here a bunch of the kind of categories of use cases. And I'll show on the next slide that have tended to be where private wireless systems seem to be a good fit. And it really is for not just general connectivity, but usually live area coverage, needing security, needing predictability, and also very small, high density coverage areas. So we have on our website, and there's a link here, an ebook. This is updated almost monthly, in which there is probably 40 different use cases across all these different verticals that are success stories. And it's not only a summary use case, you can also click and get more details in the announcements. And we at the Ongo Alliance are happy to make introductions. If there's something you see there and you want to talk to some of these companies, we will help you do that. We will help make those connections. Of course, we'd like everyone here to join the Ongo Alliance and participate. But rather than me going through a whole bunch of use cases that are on there to 40, I'll just say those are there. Please use them as a reference. But I will cover 2 use cases that I think are, and these are more early adopters that the federal government did, and I have personal experience with them, so I'm going to highlight them. They were done out of OUSD, that's Officer Under Secretary of Defense, Research and Engineering budget. And the nice part about these deployments is they went all in. They not only did the 5G or the private wireless network, they also did all the applications, and they put a small army on these tasks to make sure they were secure, that they operated right, and collect the metrics of why and how these are successful to build the business case and the ROI. So I'm going to use these, and you'll have to, and they're also dual use. So they are, while they're military environments, they're actually applicable to the commercial market. The first was Marine Corps Base Albany, and there's a great video that talks about it that they put together. We put in a 4G, 5G system for a 200,000 square foot warehouse, which also expanded outdoors and expanded to additional sites on the base for a factory and a distribution center and a kitting warehouse. But it was an accumulation of about 10 use cases that were done there. And the outcome of it was, for this warehouse, they got rid of, repurposed, you don't get rid of, you repurposed 55% of their staff. So going from like 22 people in a warehouse down to 9. So that was 13 people that could go do something that was more marine-ish than counting nuts and bolts. They increased the velocity of gear from days to hours. So that's the speed at which things can get through, which improves things downrange, right? That's Amazon's model. It isn't how fast the Amazon truck gets to your house. You still got a speed limit. It's how fast your order gets off the shelf in the warehouse. And their inventory accuracy went from 70%. Probably heard in the news, the DoD hasn't been really good about passing audit lately. Up to 98%. You may have heard the Marine Corps is the only service that actually passed audit. So this transformation is doing it. Now, one of the key things they did here, and wasn't me, it was actually the application partner, is they didn't change any processes. They did not change they did digital modernization. They didn't change the processes. They changed how people and machines interacted with the process. So sometimes the OT guys will try to make it more complicated, and I'm going to go from an Oracle system to an SAP system, and I'm going to have a different process. This warehouse was the best 1950s warehouse on the planet. Okay, it was great. Everybody knew what they were doing, how to do it, but it was inefficient. But there was a process. So they didn't change that. What they did is they changed how people interacted with it. They changed that machines interacted with it. So my example there is the two biggest metrics I knew there, realized were not technology. It was Corporal Bennett, 23-year-old young lady, always grew up with a phone. She learned how to use this system and achieve these results in a day and learned the process. In a day, 8 hours training, she was converted. The other end was Donnie, 63-year-old, lifetime civilian, been everywhere, had a flip phone that he didn't like. He could use the system because we didn't change his system thing. It is how he interacted. So they had tablets, so information came to them on parts that were connected. They were able to get robots to count things in narrow aisles where Wi-Fi wouldn't work. And one of the things that happened there was the efficiencies that were gained in some of in the process. They were going to go from 65% utilization on the racks to 95% because they were able to figure out where stuff should go. Guess what? Those narrow aisle canyons became narrow aisle tunnels. So you also have to think about what is, when you improve these efficiencies, you might be changing the environment such the way you connected before. And it used to be on crowded aisles, people would have to count inventory, they would have to take the bolts and stuff out and take them out to the aisle to scan them because the scanners didn't work inside the narrow aisles. So those are some of the examples. So it's those people outcomes that are really important. Just to highlight this outdoor, we covered outdoor, and this is another thing you have to do in the enterprise is you got to change the metrics. Do not talk DBM. They won't understand it. So we compared Wi-Fi to the cellular. This was CBRS outdoor, the coverage, and it's hard to see, but this is a 1/4 mile long parking lot with a bunch of military equipment. And when we did this test, they had up-armored Humvees. God bless the Marines. 18 inches apart, front, back, side to side. Thousands of them. So we went and ran a phone with a team session, screen sharing of, an app with RSRP, and walked around and counted how many Humvees in could I get with Wi-Fi. Well, Wi-Fi was this. So when I share this with a general, it says, well, Wi-Fi could only cover this much, and it could only get 2 Humvees in. But if I did cellular, private, I could cover everything with 1 access point. So I don't need 20 or 30. And I could get all the way across 11 up-armored inside the up-armored Humvee and still have a connection. with 11, 10 others in between. That is something he could understand. And the reason they want this is they want robots because when you have a couple thousand tan and green where I parked my up armored Humvee problem to figure out which one I have to do maintenance, they wanted to automate that. So
Where are you facing that?
we put an outdoor Wi-Fi access point at its maximum power, and
So that's from within.
the within the power limits, yeah. And we're going inside the vehicle, and yeah, and then ran a live streaming session from it and recorded it.
But did you put the Wi-Fi? The Wi-Fi was going there.
No, we put it, we turned off the cellular, we put the Wi-Fi antenna at the same place as the private wireless antenna.
But that's a little bit of an apple.
What's that?
It's a little bit of an apple and orange.
Is it?
It is, because one AP is not designed for quarter of a mile or 1 mile radius. It is designed for 200 feet, 300 feet, kind of stuff. So the AP itself is not designed for large area coverage, right? Outdoor coverage.
That's my point exactly.
That is not the point. The point is, I could have achieved the same thing if I put, say, 20 APs in the parking lot.
Okay, so General, I need you to go, we're gonna do a logistics base at a forward operating area. Now I gotta deploy 20 access points versus one.
And you do not need to change any of the devices because all of your devices are connected to Wi-Fi. So you do not need SA devices, NSA devices, or any of the CBRS frequency devices, certified devices that you work on, because those do not exist today. It's part of the fact that.
But you're assuming you got this, all the access. But I know exactly, you don't have like those like do a parking lot. You do it. I'm not saying you have to have, it's gonna be fuel.
That's not true. That's not true.
That's the narrative about the equipment.
If it is a narrative that I can actually replace one RU and replace 20 APs, that's a beautiful narrative. But if it is a narrative that I can actually get better service with 5G versus the Wi-Fi, I don't see that point coming out over here, right? Because I can actually do the same thing with an existing Wi-Fi investment that they might have on farm base or whatever base they put in, right?
You can only go 300 feet versus from one AP, right? But then so we're in violent agreement.
If you have one pole in the middle of a big giant area, the metal containers need to get energy. Propagation, power level, and the factor.
I completely understand. Don't get me wrong. Cisco, right? Still on the top stuff in that, right? But what I was trying to get at is, if I take that to my manufacturing, like non-military, whatever, they have invested, like you said, 4,000 AP already in this. Then I'm going to come and say, you know what, I'm going to get rid of your 4,000 AP, Summit 3, Aruba, Ubiquity, whatever you want to call it. And I can replace it with one RU, which is beautiful. That's a rip and replace. That goes into a lot more consideration from real business case perspective. It's a great technology demonstration, don't get me wrong. I use it all the time myself. But it is, what I'm trying to get at is, how do I convince? It was easy for a board-side journalist to understand that, but unfortunately, my customers are geeks, IT geeks who have grown up with this technology for most of their life. And we need to convince them to buy it.
Right.
Not get rid of the Wi-Fi, it's improve the Wi-Fi. So,
I like that story.
right, and then supplementing it with CBRS. I'm agnostic, I like a low, our technology person.
Yeah.
But we are through asymmetric gain, we listen at 24 dBi. So we can hear those low power devices everywhere. So there's no longer 4,000. It's, you know,
North breaking the feet.
right. So, you know, we can reach, but, you know, there's use cases for both of those technologies.
Absolutely. So I love that story because it's an extension, and also I can put a story with SBA R15, I can put NW DAS, I can actually use the same code to manage your Wi-Fi in the future. You know, all that story is beautiful. I can actually put it. What I was trying to react to is I replace with one RU only from scratch, all your 20 APs, and I can get into the Humvees. Did that demonstrate my OT guy's problem effective? Like that's what I'm trying to relate it to. I don't have any business. My partners do that in Hamilton. They actually do a lot of work with the military.
Yep.
I'm actually from the 51st state. So,
Greenland or Canada? Yeah.
So we have an armed relationship, like it is and all that stuff, but I'm talking from the manufacturing side, but how do I relate this beautiful story that you showed to my OT guy?
Well, the funny thing is, so in this case, some greenfield things.
Those are rare. Those are rare in manufacturing.
Well, I'm not, this is not a manufacturing case per se, this is a big open space outdoors with a bunch of vehicles, right? You gotta put it in that context. I agree with you, when you go into manufacturing, you've already got infrastructure with AP, you've got different animals. Kurt could have equally represented and say, I want to cover this entire space with Wi-Fi. Here's how many APs and infrastructure I'm gonna have to put in this.
And then Cisco will give you 75% discount and the price point comes down from those and Ericsson, much cheaper. I can't say for GMA. But
Yeah.
it's because of price war issue.
That's why. Easy to think for, use these stuff.
Yeah.
That's what you were saying earlier, like you're talking about communications. I think what's that, the rotation highlights, right? For a general, for example, it communicates to, to a person that there is a difference between the wireless connectivity of your phone, right, or cellular and Wi-Fi.
Absolutely. Pervasiveness is a very powerful story that we need to start. Pervasiveness of the connection. But at the same time, then you get technical, oh, I want a 20 megahertz band only or 40 megahertz slice on a particular RU. Maximum I can get is 500 megabits per second uplink, it's useless, right? So those are the stories that collectively,
Right.
we, people in this room, need to have educational stories around for us to win business. No, but even though I'm from 51st state,
No.
I am in over here, I'm.
The main point of this is that general didn't even know private wireless was an option and why, because his default is, I'm just gonna do it with Wi-Fi. This opened the conversation, then we go into all the other stuff.
I'll say that's a good conversation to have, but what you're talking about, coverage area, that latency and get back to the application. We can show them our antenna. We could cover acres and acres and acres. We're doing it for 14 companies. Right? So, the same technology is this. Then we keep in mind over you got decoupling the game because all Wi-Fi traditionally has been transmit receive as symmetrical. By decoupling that, you change out. At the end of the day, though, there's one real takeaway, and that's 6 of your hours.
Yes.
Because you can all come up with a lot of technical arguments by 1%. You can watch them. It's not. This is turning into like a discussion that you stood out in there. And it's getting versus Wi-Fi versus private LTE. And the point I'm really trying to make is it needs to be kind of an overlapping Venn diagram. Yeah.
Oh, I mean,
It very much is, right? And just to a point, right?
yeah,
Been here, right? We're talking about data, what it's trying to say. I mean, all, things, Wi-Fi and device qualifiers. And there are many times, the reason I really find it when data in is really because there are technologies within wireless, Wi-Fi as well. You can see that government area of goals as well. A lot of people haven't see what they're doing. But does that complicate the situation or does that complement the situation? I think that's all we can look at. Coverage is not the only thing. right? You have to look at the problem, just the coverage problem, there are many ways to avoid them. But again, going back to my analysis earlier, right, it's an application, the technology, the criticality of the data you're transferring, the technology you're using, the spectrum you have, and how much information you get, right? You have to map it back to what that business is trying to achieve, and either pay from moving data from point A to point B, right? In this case, okay, I need to track all these systems realistically, thousands of these, vehicles that I need to track. I don't have the real estate to put 20 API. Okay. Additional coverage to it? Yes, okay. Even with single API, I can extend the coverage. Does it have the capacity to handle all of the things? Okay, can it handle my use case today? Can it handle my use case tomorrow? That's the conversation. And that's where, we have to go in this market, not having a viewpoint of I'm going to sell 5G. It's not about that. It's about finding the point, a Venn diagram where it makes sense, where it complements, where it actually, it enhances, and how do you make, the type of business better at the end of the day.
But at the end of the day, then you are addressing enterprise needs of your different of the so if you write and private part of the institution, that what we do, Bootcamp, right? Once upon I think the technology to quick. I get the question from how it is in the network has to be support this technology. The reason we are, when I said we truly believe system integrator and MSPs are the essential to this evolution, is because they have to speak both languages. They have to say there are 5 different ways to solve this, and we have figured out the right way to do it for you for this application. If we are trying to go in there selling one application, one 5G network at a time, we're never going to be successful. Yes, we convince them for something they already understand. We've already created a very clear use case. Yeah. It's not going to happen. So this problem is how we find. Only SIs who are actually investing in understanding what technology, what application make sense, how this Venn diagram work, are the ones who are going to happen.
The G said that it's not too much. It's a bunch of five data, because where we get enamored with talking about Wi-Fi versus private 5G, with public cellular still an issue. With private 5G, Wi-Fi, we now have other wireless technologies, like LoRaWAN and the upcoming Halo stuff. It has a very specific set of use cases where we target enterprise. There's still other wireless technologies that are important in these environments. Everything from ultra wideband to DOE to big state. And as a system integrator, if the aperture is not wide enough, start trying to apply technologies that don't solve the problem. You want to talk about asset tracking? You can't afford to use private fire for that.
There was no idea.
Further, that is exactly the problem people need to collectively talk about. How do we put that Venn diagram?
That's right.
That you put all of these technologies, and then one of the things that we have, I'm a 5G, so apologies for that, is that we think the life ends at UPS. Life doesn't end at UPS, actually from enterprise, all our manufacturing branches, like the first one, it starts at UPS because the real data center connection happens post UPS. So what do you do with your policies? What do you do with all that stuff? Like you can give me a great slide up to UPS. Wonderful. But if that's untranslated password, useless.
Yes, and there's still work to be done there.
Collectively talk about to win business.
Yeah.
It's all about winning business, right? Collectively. It doesn't matter whether JMA wins it or Nokia wins it or what Ericsson wins it, we all win.
No, we have to build up, and the point of this session is really building up that. But I'm gonna go back to regular scheduled program quickly, because, obviously we're gonna have some good lunch discussion. So I want to highlight another, and which is, it isn't always the outdoor coverage, it can be the indoor, and I talked about narrow aisle, but they were building this high density robotic storage system built after a leaf ant that could hold 3,600 containers. And this is where I called new meets new, in the middle of this warehouse, and it's 2 stories tall. It's huge, and it's a matrix. What we found in while we were doing this, didn't know much about it, but the robots, the ants, they called them, would have to go to the top or bottom to connect to get the next set of instructions. Found out what's the most expensive part about operating the system, which is a huge time saver. It's the maintenance on the ants. So if they could get telemetry and keep going. Oh, okay. If they could get telemetry and actually issue instructions to get diagnostics in the middle. This company tried using other technologies. I won't mention them because it'll just start a whole nother discussion. And the thing, we already had 5G flooding the warehouse. So we did connect 5G modems, similar to what Jason showed, and ran video connected. This company then, oh, this is a way I can connect. It can save 50% of my operational cost of running this thing and speed up the amount of travel time and transactions, excuse me, any ant can run by 2x. So there was a 4x gain by connecting it, and it was because of the fidelity of, even in a concentrated, of which this waveform could provide. So it was very successful. I have videos that show how that worked. I'm going to just close out here. We also, through the DoD, did a 5G Open RAN system at an airport. It was at Naval Air Station Whidbey Island. Mix of different vendors, to someone else's point, covering the whole 2-mile flight line and a couple of the big hangars. It was interesting that when we started engaging and figuring out the ROI, it wasn't like what's the coverage and so much. It was how do we get the most out of $30 billion worth of aircraft and all the training. And if I can get a fraction of a percent of efficiency or keep one more plane in the air than I could before, those are huge savings. But you know, the work is coupling those together. What was also interesting at this site was once we provided this coverage, the purples are the use cases that were applied, which were around maintenance and operations and efficiencies. Primarily, a lot of it was to get fueling on time because pilots were missing their training range times because they were very inefficient in the ground operations and for maintenance. But what was interesting, once we provided that connectivity, there was the blue use cases, and there's been several since this slide that actually showed up that nobody even thought about. $130 million physical fence was replaced with a $20 million virtual fence because now we could connect cameras instead of having a physical fence. The pilots were taking their electronic knee boards, their flight bags that are tablets, they were taking them home to get updated, which means they were time late and stuff. And now they were able to update their tablets on the way to the aircraft. So that was a safety issue. Nobody explained that was a use case because nobody wanted to tell the Navy that we were taking our tablets home to update them. That's kind of the exciting part is when you do deploy and provide that connectivity, let people go crazy. So that's all I have. Sorry I ran late, but I appreciate the discussion.
This is what we are trying to aim for, this kind of discussion.
Thank you. Well, lunch is served. We are almost a session late. We had Huxley's talk before lunch, but we'll start there. And guys, please keep coming. These kind of questions. I'm gonna, like I said, I bet you will love what you need to grant. And
Don't like it.
and then we have another great speakers, right? We have Mike presenting, Ian. Definitely, he will talk about the Wi-Fi and what the system, and very much we discuss with your language. So please grab lunch, keep the conversation going. The feedback in the room in 10, 45 minutes. Great, thank you.